Sketch the solution set for the system. Indicate whether the region is bounded or unbounded. Okay, so we're going to go a little faster this time. So we're going to pretend these are equal signs, right? So if we set x equal to 0, this term is gone, right? So if this was an equal sign, we'd see y equals 60. So we'd have 0, 60. Does that make sense? We're going to do the same thing. We're going to say what happens if y is 0. So if y is 0, this term is missing. Again, we're going to pretend this is an equal sign. So we have 2x equals 60. So x is 30 if y is 0. So we have 30, 0. Do you understand how to find those two intercepts? Hopefully so, because we're about to do it again. Okay, so the next one, x plus 2y equals 30. Remember, I'm pretending this is an equals for right now. Okay, and then we're going to let x be 0, which means this piece is gone. So we're solving 2y equals 30. So y is 15. But that's only true if x is 0. Okay, now we're going to do it again. We're going to let y be 0, which means this piece is gone. So we see that x is 30. Then we see we have x greater than or equal to 0 and y greater than or equal to 0. So let's talk about these together very quickly. We know that we classify numbers 3 ways according to sign: positive, negative, and 0. This says x is greater than 0, so that's positive, and x equals 0, so that's positive. So the only thing I'm not allowed to have are negative x's. Same thing with y. Y is greater than or equal to 0, so y can be positive, y can be equal to 0, but y is not negative. So if you think about your coordinate axis system, where is x negative? X is negative over here to the left of this y-axis, so that's not going to be my answer. And then we say, well, where is y negative? Y is negative below the x-axis. So if you have these two inequalities right here, you're going to be looking at quadrant 1. So let's look at the x and y intercepts we found, and we're going to use those to figure out our scaling. So we have 15, 30, and 60. So we need to go at least to 60. Let's go ahead and count by 10s. Let's go to 70 and count by 10. Keep in mind when I draw my axes, I don't have to worry about anything that's not in quadrant 1. I want to include a little bit of quadrant 2, 3, and 4, but my focus will be quadrant 1. 10, 20, 30, 40, 50, 60, 70, 10. Okay, if you're going to use tick marks that represent digits other than 1, you need to say so. So we're going to plot these. We have 0, 60 up here, and 30, 0 right here. Now notice this inequality has an equal sign, so we're going to use a solid line. And we label it 2x plus y equals 60. Let's look at the other one. X plus 2y greater than or equal to 30. We're going to plot 0, 15. Now notice this is 10 and this is 20. So 15 is halfway in the middle. I'm going to put a point right there, 0, 15. And then 30, 0. Also, this inequality has an equal sign as well, so we know it will also be a solid line when I'm drawing it. Now we're going to figure out the shading. We've already discussed that x greater than or equal to 0 and y greater than or equal to 0 are going to give us a region in quadrant 1. So let's look at the other two inequalities. So let's look at 2x plus y greater than or equal to 60. Let's pick a test point that is not on that line. Well, this is my line right here. 0, 0 is not. 0, 0 is easy, nice and convenient. Remember, x is 0, y is 0. So when x is 0 and y is 0, this side becomes 0. 0 greater than or equal to 60 is false. So we're going to shade the side without the point 0, 0. So here's 0, 0. We're going to shade the other side. So we're shading this way. Let's try the next one. We have x plus 2y greater than or equal to 30. This line right here. Here's 0, 0. 0, 0 is not on that line. So we plug in x equals 0, y equals 0. Left-hand side becomes 0 greater than or equal to 30. That is also false. So we're going to shade the side of that line, again, without that point 0, 0. So we're going to shade this way. Okay, so what do those pieces have in common? If we extend the arrows, we see that all of this is shaded, and then we extend these arrows, all of this is shaded. So just looking at the two of those, we'd have this boundary, right? But we also have to consider that x is greater than or equal to 0 and y is greater than or equal to 0. So we're also going to consider anything that's in quadrant 1 and only in quadrant 1. Because I'm in quadrant 1, I cannot have this section right here that's to the left of the y-axis, or this section down here that's below the x-axis. Okay? So actually, we're going to have this y-axis as a boundary, and then this line is a boundary, then this is a boundary. Okay. So the blue region that I've shaded is my feasible region, S. Okay. We see S is unbounded this time. Cannot completely enclose that in a circle.